Okay, so the hoisting in a JavaScript means move the declarations of functions, var variables or classes to the top of their scope, and that is due before execution of the code. Also, let and const also get hoisted and returns reference error if they used before the declarations. Initializations are not hoisted, just declarations part is get hoisted. So see here in example, we have declared var x equal to 13. This just var x, this part only will get hoisted, and the x equal to 3 will not get hoisted. It will stay and remain on the same line. Okay, then the next is null versus undefined. So null, it means it is the intentional absence of the value, and undefined, it means the value does not exist in the compiler. So type of operator for null will return the object, as this is the known bug in JavaScript, and the type of undefined will return undefined. So the null equal to undefined will be true, but the null triple equal undefined will be false, because the type of null is object and the type of undefined is undefined. So the next is a scope. Scope is the area where an variable is accessible to. Where a variable is accessible to. Scope is the current context of execution, and the scope is the context in which value and the expressions are visible or can be referenced. There are two types of a scope, local and the global. And also ES6 added block scope using the let and the const declarations. So we'll see the local and the global scope. Global scope means the outside of a function, and the local or function scope means the within and inside the function. Okay. Then the lexical scope. A lexical scope means the place where a variable or a function is declared. The initialization of a function or a variable doesn't matter for the lexical scope. For example, we have declared var a, we have declared var z, and assigned the value for 80. Then we have declared the function outer, and we have declared the var b, and we are then assigning a value to the a variable which is listed in a global scope. Then we have a function inner declared inside the outer function, and then we have assigned a value for b variable as a 20. So we have declared three variables and two functions in this program. So we'll see the lexical scope of each variable and the function. So we have listed this a function, a variable, and the z variable and the outer function in the global scope. So for these three, the lexical scope for these three is a global scope. Then we have declared variable b and the function inner in the function outer. So the lexical scope for variable b and the function inner is the outer function scope. So as we have assigned the value for a in the outer function scope, and the value for b we have assigned in inner function scope, but this initialization doesn't matter for a lexical scope. It matters only where they are listed. Okay, so the next is a closures. Closure is the combination of a function bundled together with the references to its surrounding state, that is the lexical environment. In other words, a closure gives you access to an outer function scope from an inner function. Sometimes even the outer functions get executed, we have access to the uh, inner function, and the via inner function we can access the variables of the outer function. So this mechanism is useful, like we can use the private variables using the closures, we can hide the internal implementation from a user using the closures. So as we see here, we have declared one function, uh, and we have declared the counter variable. We have declared the inner function plus, which will access the variable uh, from the lexical environment, and it will add one. And when we call the add function, this function will return this plus function. As we see here, by calling add function, this returns the plus function, which is having access to the counter variable, which is lexical for this add function. So in this function, even the add function gets executed, counter the plus function has access to the counter variable. So we usually we use the closures in this fashion, but every function in the JavaScript has a closure. So when we create any function, JavaScript engine will create the closure for that function. Okay, so the next is this keyword. This keyword refers to an object, but which object is depends on where we use this keyword. Like this refers an object, but it depends on that which object it depends on where we have used this keyword. So we will see some situation where this keyword refers to which object. Suppose we use it alone, this will refer to the global object. In object method binding, this refers to that object. In a function, this refers to global object in a function, but in a strict mode, this keyword will be undefined. In an event, this keyword refers to the element that received an event. Methods like call, apply, and bind. This keyword refer to the past object while creating or calling the function using call and apply. Yeah. Okay, then call, apply, and bind function. These functions are used to uh, reuse the functionality. So call and apply invoke the function, but the bind function will create a new function and later we can call it. Call and apply takes the first argument as object for the reference in a function for this object, this keyword. Then bind takes the object reference for this while creating a function. Call takes comma separated arguments and apply takes argument as an array. Then the function chaining. Function chaining means grouping the functions in one single line using dot notation. It uses this keyword to make enable function chaining. This type of chaining makes the code very concise and also improve the performance. So for example, we have this function pizza, and it has a method like make a base, add pizza sauce, add toppings, and while calling this using the function chaining, we'll create one object assigned to a variable, and then we'll call the all the methods by dot annotation like this: pizza dot make base dot add pizza sauce and add topping. So the key of the function chaining is this statement return this. We are returning this from every method. Actually, we are returning the instance of pizza in every method, so that's why this is possible to add all the functions in one line. Okay, so the next is a higher order functions. In JavaScript, functions are treated as a first class citizens. We can treat a function as a value and assign that function we can treat a function as a values and assign them to another variables. we can pass them as an argument to another function, or even we can return them from another function. In this way, we treat the functions as a first class citizens. A function which takes another function as an argument or returns a function is known as a higher order function. So higher order function allows us to abstract over actions, not just values. Passing a function as an argument to another function, like we use the array dot filter. Array dot each, we have lots of methods of arrays where we pass a callback function to this filter function, and like closures, we returns a function from a function. This is called as a higher order functions in JavaScript.